So yesterday we started the chapter number 15, that is Introduction to the Polymer Chemistry. In this chapter, we already discussed what is meant by polymer, what is meant by monomer, then classification of different polymers in this, natural polymers, then synthetic polymers, semi-synthetic polymers. All this part is completely yesterday. Then linear polymers, straight chain polymers, branch polymers, then what is meant by network or cross-link polymers, then classification based on method of preparation or polymerization process. There are three methods of polymerization in this: addition polymerization, in which chain grows across the double bond; then condensation polymerization, in which chain grows stepwise; and ring opening polymerization. So this addition polymerization and condensation polymerization is explained yesterday. This mechanism of free radical, how the addition polymerization is formed, this is also explained. So today we will start the next part, that is the ring opening polymerization. Yesterday we finished the lecture to this point. So again I am explaining what is meant by ring opening polymerization. In this ring opening polymerization, as the name itself suggests, in these polymers, the monomers having the ring, and ring is opened and the polymer is formed. So this is a caprolactam, and this is a specific caprolactam that is having epsilon caprolactam. So what is meant by epsilon? This is a Greek letter like alpha, beta, gamma, delta, and the next one is epsilon. So epsilon caprolactams having the 7 members in the ring. See here, 1, 2, 3, 4, 5, 6, 7. When 7 members are in the ring, these are called as epsilon. For alpha, there are 3 members: beta having the alpha 3, beta 4, then gamma, then delta, and then epsilon, like this. 3, 4, 5, 6, 7. Alpha, beta, gamma, delta, and epsilon, like this. So this is a epsilon caprolactams having the CONNH group is there, that is amide linkage is there. This amide bond will be broken at the temperature 533 and 543. In presence of water, we will get the nylon 6. So this nylon 6 is many times asked for board exam, so make a practice at your home. And the elemental composition, I will explain what is mean by elemental composition. Means if there are 5 CH2 groups are present, all the 5 CH2 groups will be present in the polymer also. So there is no any loss of molecule. This is called as elemental composition of the repeating unit in the polymer. The result same. Means whatever the number of carbons, number of hydrogens, then number of nitrogens, it will remain same in the polymer. This is called as elemental composition. Then classification based on intermolecular forces. I already explained. Depending upon the intermolecular forces, the polymers are classified, and intermolecular forces are van der Waals forces, then hydrogen bonds. And these are intermolecular forces. These are present between the two molecules. So the mechanical properties of the polymers, for example, some mechanical properties are given here. For example, tensile strength. Tensile strength is nothing but the hardness between the two molecules. That is called as tensile strength. Then toughness, that is called as hardness, and elasticity. These properties widely differ, and these are depending upon the intermolecular forces. If the intermolecular forces are changed, these properties are also changed. So we will take one by one examples. First one is elastomers. These are the elastic polymers. Remember, in 2017, one question is asked for board exam: write a note on elastomers. So what is expected to write, I will explain. These elastomers are the elastic polymers. They are having weak van der Waals type of intermolecular forces. Remember, this sentence is very important. If you didn't write this sentence, you will lose your marks. So first we have to write down elastomers. These are elastic polymers, and they are made up of with weak van der Waals type of intermolecular forces, which permit the polymer to be stretched. You know, these elastomers, when the force is applied on both the sides, these polymers can be stretched, and if the force is removed, they can come to the original position. Why this is happening? Because some few crosslinks are present in the chains. You know about the crosslinks. I already explained in the crosslink polymer. So some crosslinking present in the elastomers, they help the stretch polymer to retract to the original position. Retract means when the force is released, they come to the original position, and this is possible due to the crosslinks. So these polymers having some properties, they having the elasticity, these are very soft and stretchy, we can stretch it. Then elastic tearing is prevented, means when the force is applied from the both sides, the polymer cannot be broken. So this breaking is, that is also called as tearing, that tearing is prevented due to the cross-linking. And these are used in making rubber bands. Some examples are given here. These are the examples of elastomers, neoprene, this is a vulcanized rubber. All these are synthetic rubbers. Then Bunayas, Bunayan, all these are the examples of synthetic rubbers. All these are prepared in a laboratory. In the next part, I will explain what is meant by vulcanized rubber. So these are the some pictures are shown. These are the rubber bands. These are elastomers, and this is a rubber. This rubber is synthetic rubber. So if the question is asked, write a note on elastomers, you can write all these points. Then next one is fibers. So what is meant by fibers? I will explain first. Polymeric solids. These are the solids which forms threads. These are called as fibers. Then the fibers possess high tensile strength, which is a property to have resistance to breaking under tension. Means they cannot easily broken, the fibers. This particular property of the hardness is due to the strong intermolecular forces like hydrogen bonding. See, in case of fibers, strong intermolecular hydrogen bondings are present, and strong dipole-dipole forces. And in case of elastomers, if you see in elastomers here, weak van der Waals forces are present. That's why the elastomers can be easily broken. But the fibers having the strong intermolecular forces like hydrogen bonding, so these cannot be broken easily. They are having the high tensile strength. Due to these strong intermolecular forces, the fibers are crystalline in nature. For examples, polyamides. All the polyamides means they contains amide linkage, CONH linkage. All the polyamides, nylon 6,6, then polyester, styrene. These are the examples of fibers. See, when example is shown, all these are called as nylon ropes, fibers. Then thermoplastic polymers. Thermoplastic polymers, remember the example of PVC pipes. Thermoplastic polymers means if the polymer is heated, if these PVC pipes are heated, you know, PVC pipes are heated, they becomes soft, and after cooling, they becomes hard. So thermoplastic polymers having the property, if these are heated, they become soft, and when cool, they becomes hard. So they can be remolded. We can remold it. These polymers possess moderately strong intermolecular forces. This is a very important sentence. Moderately means not strong. Moderately strong intermolecular forces that are intermediate between elastomers and fibers. So thermoplastic polymers having the properties between elastomers and fibers. And examples are polythene and PVC pipes. So this may be asked for board exam for 2 marks. Write a note on thermoplastic polymers. So remember, one important thing is heating and cooling. After heating, they become soft, and after cooling, they becomes hard. So opposite to this thermoplastic polymers, there are another type of polymers. These are thermosetting polymers. These are exactly opposite to the thermoplastic polymers. Thermosetting polymers, these are rigid polymers. Rigid means these are very hard. During the formation of these polymers, they have property of being shaped on heating, but they get hardened while hot. I will show some examples, then you will understand. So these are the examples of thermosetting polymers. See, these are the electrical switches. Then this is a old telephone body, and this is used for making the toys. All these are examples of thermosetting polymers. And what is the difference between thermosetting polymers and thermoplastic polymers? I will explain. If these polymers are heated, the if these polymers are heated, what is happening? They form a fusible mass. Infusible mass is prepared, and these cannot be reused and remolded, because if these polymers are heated, they forms a infusible mass and they cannot be softened. After heating, they cannot be soft. They forms a infusible hard mass, so cannot be remolded. And this property is due to the extensive cross-linking by the covalent bonds. Remember. So these polymers cannot be soft after heating. They forms infusible solid mass. That's why they cannot be remolded. And this infusible mass is formed due to the extensive cross-linkings are present in the polymers. And the examples are bakelite, remember. So this bakelite is a thermosetting polymers, cannot be reused, cannot be remolded. Then the next last type of classification is classification based on different monomers. The polymers are divided into two classes. First one is homopolymers. The name itself suggests these polymers are prepared by only one type of monomer. And another type is copolymers. These copolymers can be prepared by two or different types of monomers. First, I will explain what is meant by homopolymers, and then I am coming to this type, copolymers. So this is also important for the board exam. For the short note, it is asked, write a note on homopolymers for 2 marks and write a note on copolymers for 2 marks. So what is expected? We have to write the definition and we have to write only examples. So addition polymers, homopolymers, these are the addition polymers formed by the polymerization of only one type of monomer. This is very important. These are prepared by only one type of monomer, and these are called as homopolymers. Monomers having the same structure. See the examples here, polythene, then nylon 6, nylon 6,6. But in case of copolymers, at the name itself suggests these are heteropolymers. These are also heteropolymers. These polymers are prepared by the polymerization of two or more different types of monomers. This is the main difference in between homopolymers. Homopolymers are prepared by only one type of monomers, and copolymers are prepared by two or more different types of monomers. The different monomer units are randomly sequenced in the copolymer. This is with this line is very important. The different monomer units are randomly sequenced in the copolymers. Sometimes in case of homopolymer C, in some cases the repeating unit is formed by the condensation of two distinct monomers. I want to give one example. This nylon 6,6. Nylon 6 is already explained. This is prepared by the caprolactam, but this nylon 6,6 is a condensation polymer. It is prepared by the adipic acid and hexamethylene diamine. Though there are two different monomers are used, this is included in homopolymers, because in some homopolymers the condensation also takes place. But how to identify it is a homopolymer or copolymer? By using this a sentence is given. The different monomer units are randomly sequenced in the copolymer. If the monomer units are randomly sequenced in the copolymer, in the polymer, that is called as copolymer, remember. So this is quite confusing, but only remember this nylon 6,6 is an exception. Though for the preparation of nylon 6,6, two different monomers are used. This is exception, and it is included in homopolymers. And copolymers, it is clearly seen two different monomers are there. See the example, it is 1,3-butadiene and styrene. These are the two different monomers, and the polymer is formed by it is a Bunais. It is a synthetic rubber. I will explain what is a 1,3-butadiene here. Butadiene means there are 4 carbons, 1, 2, 3, 4, and on the first carbon and third carbon there is a double bond. See if this is the number 1, 2, 3 and 4. On the first carbon and third carbon, there is a double bond. So it is 1,3-buta and a diene, because two alkene groups are there. And this is the styrene. This is the styrene, means benzene ring is there, and CH double bond, CH2. It is also called as phenylethene. Styrene is also called as methylethene. And just these two molecules combined. Detail I will explain in next slide, because the preparation of Bunais is also included in the syllabus. So this is very important. Remember, this nylon 6,6 is exceptional, though it contains two different monomers. It is included in homopolymers. Then classification based on the basis of biodegradability. Non-biodegradable polymers means most of the synthetic polymers are not affected by the microbes. So they do not degrade naturally. These polymers are very dangerous for the environment also, and they stay a very long time in the nature and causes pollution. One example is, thermocol. Thermocol requires 1,000 years to degrade. So biodegradable polymers, these are the polymers, as the name itself suggests, biodegradable. They can degrade, they can decompose naturally by the microorganisms. For examples, these are for PHBV polymer, nylon 2, nylon 6. These I will explain in the special slide, classification based on biodegradable. Just in this slide, we have to remember what is meant by non-biodegradable polymers and what is meant by biodegradable polymers, which can degrade naturally. These are biodegradable, and those polymers which cannot degrade naturally, these are non-biodegradable polymers. Then preparation of some important addition polymers. See, already I explained addition polymers. Chain grows across the double bond. There is a polythene is a good example. There are two types of polythenes, remember. One is high density polythene and one is low density polythene. Always it is asked for board exam, remember, how this low density polythene is prepared and high density polythenes are prepared. So there is a difference in the reactions. What is meant by low density polythene? See this structure. Purposefully I have given this structure because low density polythenes, these are branched in structure. See, the branching is there, and high density polythene is a linear polymer. So if the question is asked for board exam, which of the following is branch polymer and which of the following is linear polymer, remember, always low density polythenes are having the branch structure. See how it is prepared. This is the ethene molecule. LDP, it is a short form of low density polythene. Low density polythenes, these are prepared by the polymerization. Methods of preparation of polymers are called as polymerization. These polymers are prepared by the polymerization of ethene under high pressure. See, the pressure is 1000 to 2000 atmosphere, and the temperature is 350 to 370 Kelvin, in presence of dioxygen. Traces of dioxygen means little dioxygen we have to use, and peroxide it is used as a catalyst. So by using such conditions, we get here low density polythene. As the name itself suggests, it is having the low density, it is having a branch structure. These polymers having the branch structure. Yes, one typing mistake is done by me. These polymers having the straight chain, sorry, this is correct. These polymers having the straight chain structure with some branches are there. So this is a straight chain structure and some branches are there. So this is a branch polymer. As a result, chains are loosely held. These polymers having the low density. This is important. Why this is low density? Because these chains are loosely held. That's why it is low density. And what are the properties of this low density polythene is, low density polythene films are extremely flexible. These are very tough, chemically inert, and moisture resistant. It is a poor conductor of electricity, and the melting point is 110 degrees. Due to these properties of low density polythenes, so where these polymers are used, see, it is mainly used in the preparation of flexible pipes. Flexible pipes are prepared by using the low density polythene because these low density polythene films are extremely flexible. Then these pipes are used for agriculture and irrigation and domestic line purpose. This is not important for us. Only this is important for the preparation of flexible pipes. Also, these are used as a insulation to the electric cables because these are poor conductor of electricity. And then second use is also these are used for in submarines. Submarines, these are under the water for the cable insulation because they are having the property of the poor conductor of electricity. These are used. Then it is also used in the production of extruded films and sheet, mainly for packaging. It is also used for the manufacturing of squeeze bottles. You know these squeeze bottles. I have also shown this picture. These are the squeeze bottles and toys and also the attractive containers. So these are the low density polythenes. Now I am coming to the high density polythene. High density polythene is a linear polymer which is having the high density due to close packing. Remember, high density is due to the close packing, and low density polythene or low density low density polythene is having the low density because the chains are loosely held. This is prepared again by the ethene. So this is ethene, but the conditions are different here. See, the temperature is 333 to 343, and for the low density polythene, see the conditions here. The temperature is 350 to 370, and see the atmospheric pressure here, 1000 to 2000 atmosphere. And see the atmospheric pressure in high density polythene is only 6 to 7 atmospheric pressure. And the catalyst used is very important here. The very important catalyst is used for the preparation of high density polythene, and the catalyst name is Ziegler-Natta catalyst. See here, I have given the combination what is meant by Ziegler-Natta catalyst. Ziegler-Natta catalyst, which is a combination of triethyl aluminum with titanium tetrachloride. See in bracket, the combination is given tri. There is a triethyl aluminum plus titanium tetrachloride. This combination is many times asked for board exam. Remember, what is the combination of Ziegler-Natta catalyst? And Ziegler-Natta catalyst is used for the preparation of high density polythenes, not for low density polythene. So the properties of the high density polythene and low density polythenes are different. High density polythenes are same properties. One property is same. This is also the chemically inert. They do not react with chemicals and more tough and hard than the low density polythene. Then second property is it is a crystalline. Melting point is in the range between 144 and 150 degrees. So the melting point, see the check the melting point. Melting point is also higher than the low density polythene. It is much stiffer than low density polythene as and having the high tensile strength. Hardness is also more. So it is more resistant to chemicals than low density polythenes. So what are the uses? Uses are given here. These uses may be asked for board exam for 1 mark or 2 mark. So high density polythene, it is used in the manufacturing of toys and other household articles like buckets, dustbins, bottles, pipes, whatever the household articles are using in our day-to-day life. These are made up of with high density polythene. Buckets we are using in bathrooms and for many purposes. Dustbins, bottles, pipes, these are all made up of with high density polythene. Remember, if you understand now what is mean by low density polythene and high density polythene, we never use this word plastic now further, because you understand now because it is made up of with high density and low density. Second use, it is also used to prepare the laboratory wares and objects where stiffness is required. Stiffness is nothing but the hardness is required. In our chemistry laboratory, many instruments are prepared with this high density polythene. For example, we are using the conical flask also, that is then beakers also, then measuring cylinders also. All these are made up of with high density polythenes. See here, one example is given. This is a toys and dustbins. Then next one is Teflon. Teflon is also called as polytetrafluoroethene. See, this short form can be given for the board exam. Polytetrafluoroethene. This is prepared by using tetrafluoroethene. Directly, I am coming to the reaction. See the reaction. This is the n number of tetrafluoroethene. Why it is called as a tetrafluoro? Because four fluorines are there. That's why it is tetrafluoroethene. This is same as ethene molecule. Instead of hydrogens, instead of two hydrogens only, instead of four hydrogens, four fluorines are there. That's why it is called as tetrafluoroethene by using the catalyst and per sulfate catalyst it is used at high pressure. We get the Teflon here. So what are the properties of this Teflon? This is a chemically inert, tough, resistant to heat, and attacked by corrosive reagents. As this CF bond is very difficult to break. See, this Teflon having the CF bond, as this CF bond is very difficult to break, and it is remains affected by the corrosive. Yes, we will start again. There is some internet issue. Yes. So this, as this CF bond is very difficult to break, this CF bond is very difficult to break. These polymers are used for making the oil seals and gaskets, also used for non-stick surface coated utensils. In our day-to-day life, this Teflon coating is used for the vehicles, also for in automobiles, also for making non-corrosive. As these they are having the properties of non-corrosive, these are used for automobile industry also. These are used for making utensils also. And one important use is these are used in making oil seals of the automobiles and gaskets. These are present in the automobile engines. So this one important thing. This is also asked for 2 marks for the board exam. Remember, elastomers it is also asked for 2 marks. Then nylon 6 preparation. Then Teflon. Then high density polythene. Then low density polythene. So make a practice at your home. Write these reactions. Then next one addition polymer is polyacrylonitrile. Polyacrylonitrile, this short form is PAN. This is a P stands for polyacrylonitrile, or it is also called as Arlon. So this Arlon is prepared by using the acrylonitrile, or it is also called as vinyl cyanide. This is vinyl cyanide undergoes polymerization in presence of peroxide catalyst. This is a peroxide is used as a catalyst, and we get here the polymer is called as polyacrylonitrile. It is also called as Arlon. See, this is remember acrylonitrile. It is also called as vinyl cyanide. It is also called as vinyl nitrile. Different names are there, so don't make confusion at the time of board exam. They can confuse you by using different names. Here acrylonitrile it is used. At the time of board exam, they will give how the polyacrylonitriles are prepared by using vinyl cyanides. They will confuse you, so don't get confused. Though the names are different, the reaction is same. So what is the use of this polyacrylonitrile? I will explain. This polyacrylonitrile is a substitute for wool. Is a substitute for wool, means this is an artificial wool actually for making the commercial fibers. Like these are used in blankets also, shawls, then sweatshirts, sweaters, because it is a substitute for wool. This is artificial wool prepared in a laboratory. Then preparation of nylons, nylon 6,6. Just I explained this nylon 6,6. It is prepared by the condensation polymers by using this adipic acid and hexamethylene diamine. Though there are two different monomers, it is included in the class homopolymers. Again and again, I am going to explain you this nylon 6 is exceptional. 100% it will be asked for board exam, because according to the definition of homopolymers and heteropolymers, students will get confused, because in case of heteropolymers there are two different types of monomers. Here also there are two different types of monomers, but the main condition is the monomer having the random sequence. But in this, the monomer do not having the random sequence. That's why these are included in the class homopolymers, remember. So this is adipic acid. Adipic acid is a dicarboxylic acid. In the chapter aldehyde ketones and carboxylic acids, I explain what is this adipic acid. CH2, 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 4 times. This is a condensed formula of adipic acid plus hexamethylene diamine. At the name itself, hexa. Hexa means 6 methylene. 6 methylene groups are there, and diamine means this is a one amine and this is another amine. So this is a adipic acid, hexamethylene diamine. Condensation takes place here. Condensation means these two molecules are joined together, and water molecule or ethyl alcohol molecule will be removed. So 553 temperature at high pressure. See, these two chains are joined together and the water molecule is removed. We will see how this is removed. NH. First, see this example, CH26. This is CH26. CH26. Then here is NHCO. See, this is CH26. I will explain this one. Yes, NHC means one hydrogen here from the NH2 and this COH. It will be removed when they gets combined, and the CONH bond is formed here. See, this CONH bond is formed. So just it is only the condensation of these two monomers. Water molecule is simply removed, and we get the nylon 6,6. Now, why it is called as nylon 6,6, I will explain. See here, there are 6 carbons, and there are also 6 carbons. These are the 4 carbons of the CH2, and this is a 5th CO, and this is the 6th. So these 6 carbons are repeated. That's why it is called as nylon 6. Nylon 6,6. Because there are also 6 carbons and there are also 6 carbons, so the name is nylon 6,6, remember. So this nylon 6,6 are used for making the sheets, then bristles of our brushes, and in textile industry, these nylon 6,6 is used. Then this nylon 6 is already explained, so I am just going to the uses of this nylon 6. These nylon ropes are crystalline, you know. These are very hard, insoluble hydrocarbon solvents having the good sensation. Where this is used is very important. They are used for making brushes. What are the different brushes we are using for the cleaning purposes? So the making the bristles of the brushes, it is used. Then scrubbers, these are used for the cleaning of utensils. Then in different saris, these are used because these are fibers. And then these are used for ropes preparation. Then fishing nets. Fishing nets are prepared by using these nylons. Then different shirts, the bed covers, toys, pens, tire cords. So these are the uses of this nylon 6. Then next one is polyester. This is a condensation polymer now. Esters. These are also called as dacron, dacron or terylene. Dacron or terylene, this is another name for polyesters. As the name suggests, these are the monomer ester, and from this ester, polyester is prepared. So this is prepared. Yes, see this by taking example, it is very easy to explain. This is ethylene glycol. This is ethylene glycol is another name is ethane 1,2-diol. Ethane 1,2-diol. This is alcohol having the two OH groups, dihydric alcohol. Plus this is a terephthalic acid. Terephthalic acid is a common name, but the IUPAC name is very easy. Benzene 1,4-dicarboxylic acid. This is benzene, and at the first position and the fourth position, 1,4-dicarboxylic acid is the name of this terephthalic acid. And this is the condensation takes place only. As this is a condensation polymer, only the water molecule is removed, and these two chains are this is a COO. COO means this H and this OH of the glycol, it is removed, and these two chains are combined and the water molecule is removed. Another possibility, we can use the dimethyl terephthalate, DMT. It is called as the DMT. Instead of this terephthalic acid, we can use a dimethyl terephthalate. Then methyl alcohol molecule is removed. Means we can use this terephthalic acid also, and we can use the dimethyl terephthalate. But this reaction is not shown. See, what are the uses of these polyesters? It is used for making the wrinkle-free fabrics. Wrinkle-free nowadays, it is very familiar. All the students knows what is the wrinkle-free. Ironing is not required for the wrinkle-free fabrics, and these are blending with cotton. So these are blended with terrycot and also the wool. It is called as terry wool, terrycot, terry wool fibers. See, for the preparation. Then second one, it is also used for the glass reinforcing materials in safety helmets. So hardness, for making hardness, so it is used glass reinforcing material in safety helmets. Then I will explain the polyester and we will stop here. Then PET. PET is a polyethylene terephthalate. Most common, this is a thermoplastic polyester. It is used for making many articles like bottles, jam, packaging containers. Then polycarbonates. These are the another kind of polyester used in CD, bulletproof glass, then car headlamp, lenses, baby feeding bottles. Then for the roofing of the automobiles, and for the roofing of many structures, for the architecture also it is used. Then eye lenses, this is important. Eye lenses are prepared with these polycarbonates. So the uses are very important for the board exam. Uses will be asked. So don't neglect the uses. This phenyl formaldehyde related polymers, this is non-evaluative for this year. So